Good morning, everyone. Today is the 11th day of the Corona crisis, and by now I've checked the first assignment that everyone handed in. Most of you actually did pretty well. I can't say that I was disappointed. Some of you have already handed in assignment 2. Remember, the deadline is tomorrow. If you're watching this today, which is a Monday. And is it true? I'm actually not sure, to be honest. Check Teams for the deadline. Sorry for being not very clear right now. Anyway, in this video we're going to look at chapter 8. I actually wanted to start with chapter 5, but in the current situation, chapter 8 is pretty relevant, which made me choose to do it right now. Hopefully that's a good choice. Who knows? So what are we going to do in chapter 8? In chapter 8 we're going to look at something that we will call an exponential function. And exponential functions, we'll have to do something with that table. Talking is really hard today. And we'll see that there is something exponential about that. In the news right now, there's a lot about exponential growth, because if you look, for example, at this table, it's about country X. I just came up with it, and also with the numbers. And people with the coronavirus tend to say there's an exponential growth. But what is exponential? If you look at these numbers, most of you would probably say, okay, over here it increases with 20. Over here it increases 24. These are the amount of cases at day 1. So at the first day of this table, there were 100 cases. The second one, 120, and so on. Plus 29. And you can see that the increase gets bigger. And over here it's plus 42. And the amount by which it gets bigger as well. So how does this work? If you look at this like with absolute numbers, then the change will only keep increasing. But if we are looking at it from a multiplication factor standpoint, then you could say the following things. So I'm going to draw it again just to make sure you get what I'm saying. Use the same numbers. I actually think that one is incorrect, so I'm going to check again. Yes, my battery is low, I know. It actually seems to be correct. And this was 249. Instead of saying plus 20 cases, we can also say the amount increased, and it increased with a multiplication factor of 1.2. Why? 100 times 1.2 is 120. Then over here, times 1.2 again, times 1.2, times 1.2, times 1.2. So there's one thing which doesn't change, which is the multiplication factor. Whenever you see something like this, it's called exponential. There's also a formula which has to do with exponential functions. You already saw the general formula for linear functions. For linear functions, it was fx equals ax plus b. For exponential functions, there are multiple ways of writing it down. Usually people write down n, between brackets t, equals. Now you have to think. You have some starting point, 100. 100 in this case, and we are going to multiply with 1.2. How many times? It depends on which at which they were looking. So times, what is it? G to the power of t. This needs some further explanation. So in this case, starting with 100, and I actually chose really inconvenient numbers on top, but let's show this with a second example. So if you're looking at money, for example, and you deposit money at a bank, and imagine you have 1,000 euros. And let's come up with something really unrealistic. You get a fixed interest of 5% each year. That means that at the end of every year you get 5% of the money extra on your account. This is our starting amount. Money. This 5%, we can turn that into a growth. In your textbook they call it a growth factor, but it's basically a multiplication factor, which is basically the two words for the same thing. It's basically you go from 100% to 105%. You have to divide with 100, so the multiplication factor is 1.05. If we use these two numbers in our formula, the formula will become NT is 1,000 euros times 1.05 to the power of t. So at the start, at t equals 0, we have 1,000 euros. Then, after some time, after 1 year, well, you get 5% interest, so that means you have 1,050. But if you keep on doing this, for example, when you're at year 5, you could type in 1,000 times 1.5 times 1.05 times 1.05 and so on. But you can also say it's 1,000 times 1.05 to the power 5. So t is basically time. So let's use a calculator for this. Thank you for reminding me again that the battery is almost empty. Which is 1,276.28. So this is the new amount, which is an increase which is bigger than 50 euros each year. Two things are important. This number is basically where you start, your starting point, and this number shows you your rate of change. So in this case, it was positive, which meant that the number was growing. Of course, something can also be decreasing. So if you have a decrease of -2% each year, then it means you go from 100% to 98%, and then your multiplication factor 0.98. This is basically a start for this subject, and hopefully you've gotten some idea of what these exponential functions do. If you draw a linear function, it's usually a straight line. If you draw an exponential function, usually it's like that. The longer it increases, the bigger the increase actually gets. Unfortunately, I didn't roast anyone in this video, even though some of you would actually like that. But I'm sorry, no roasting in this video, because none of you are stupid enough to roast right now.